functionality, and that'll come later on in the video. Alright, so let's clear the scene so that we can try another example. And I'm going to clear this, and I'm going to create a new tab, new Python tab. In this example, we're going to try to solve a task that's a little more complicated than just selecting lights and changing the intensity. What if we wanted to, say, create a spiral type structure out of, let's say, spheres? We want to have a function that can generate a spiral. And we'll use spheres because it's an easy object to work with right now. We've seen that command before. So let's start off with the concept of how to create the sphere. We already know that to do a sphere, we can call sphere. And we know that sphere has, we got to turn on some help. There we go. We know that sphere has options. And let's open up our actual help screen and look at sphere and see some of the stuff we can do with it. And something we can do with sphere is we could set the pivot. So when we create the sphere, we could create it offset from the center. And so I think the idea of what we could do to solve this problem is to create a bunch of spheres over and over again with a pivot that's off center, and then rotate them around, say, the y-axis. And if we do that over time, we'll get a spiral effect. So we'll make use of this pivot flag. Let's go back to Maya, and let's say pivot equals. Now if we go back one more time, we see that it takes a list of 3 numbers. Maya calls linear a number, so it can be a float or an int. In this case will work. And we can either actually, we'll accept either a tuple, like I told you in the parentheses, or a list. We'll just do exactly what it asks for and give it a list. So what we're going to do is let's just give it, let's say x is 3, and then y, for now I'm just going to put 0 and 0. Okay, so this is going to create a sphere. I'm going to move this over so we can see a lot more. Okay, so we've got this here. We're going to create a sphere, and let's see what happens here. We've got our sphere. Okay, I'm going to delete this. I'm just going to keep moving through this kind of quickly. So we've got this sphere, and we want to make a bunch of them. So how do we make a bunch of them? We make a loop, just like we talked about before. We do for, and we'll call it a counter. Now, how many do we want to make? Let's say we want to make 20. Now, I told you one way to loop over numbers is there's a command called range. And if you put a number in there, you get a list generated for you that you can loop over. So if we say for I, and I is just our counter, we can call it anything, in range, create 20 spheres. So if I run this right now, I just made 20 spheres all on top of them. And you can see that by moving, and you can see there's 20 spheres in there. If I select them, you can see all the spheres. So again, let's delete that, and we're just building this bit by bit. So we're creating 20 spheres, and what we want to do is vary the height so we can create them over time. So this is the height, y, and we want that to increase over time. So what we could do is we can start height equals 0. That's our height attribute, and over time we're going to increase that. And so we can say, instead of saying 0 every time, let's set y to height. If I run this now, we're still going to get 0 because we're not making height any bigger. But what I can do is every time after I make the sphere, I can say height equals height plus a certain amount of increment. Let's just say 1. And if you remember, we can actually make this shorter. We can say plus equals 1. So every time this loops, it's going to create a sphere, and it's going to increment the height by 1. Let's see what happens. Okay, so we're getting closer. We've got spheres going up in the air. Okay, let's get rid of all these. I probably could have just undid it. There we go. That's much easier. Okay, so we've got spheres going straight up in the air. Now that's getting closer, but we need them to go around in a circle. So because we're using a pivot and they're offset from the center, let me just do this one more time so I can show you. Because they're offset from the center, we could actually use, the rotate value and rotate them over time. So let me select them all and get rid of these again. Okay, and so what we want to do next is, let's do commands, and to set an attribute, if you remember, we do set adder. All right, and then now we didn't save our name. We need to know the name of the sphere each time. So let's come back to this for a second. Let's create a name for our sphere. Let's say this name equals spiral sphere, and we want to make this unique. So every time that this loops, I is a new number. So we could tack on I, and we could say plus I. Now if you remember from earlier, if we try to add an int, which is going to be an int out of here, and a string, we're going to get an error. So we could do either force this to be a string, or I could teach you something really cool to stop having to force things to be the string like that. There's a thing called string formatting, and it's okay if you don't remember this, but I'm just going to show you another way you could do this. What you can do is you can put little patterns, little wildcard patterns in here, or placeholders, where you do %, and for a string, it's the S key. If you wanted to force something to be a digit, you could put the D key, but if you put a %s in here, you're creating a pattern. And so what happens is, and let's not do a space. Spaces aren't very nice, so we'll do an underscore. And what happens is you can tell it what to replace those with by doing a %i, like that. And I could have more patterns in here. I could put %s again, and if we do that, we need to wrap this like that. But let's just keep it simple. So every time this loops, it's going to be called spiral 0, spiral 1, spiral 2, and we've got to save the name. Let's say parts. And let's get some more room here. Okay. Let's call this parts, because we know from the past that sphere is going to return a tuple of, or a list of, the first index is the transform, the second index is the shape. So, and also we want to make sure that we give it our name. So every time it creates one, it will give it our name. And so we are going, so okay, so it's going to create the new name. It's going to create a sphere with our name, with our height each time. And we want to make sure that we get the transform every time. So that is parts 0. And I'm going to stop here and let us see what we're doing. Okay, and we can do that by putting a print in here. So let's see at the end of this. Let's see what print transform and height. Okay, so we're checking ourselves as we're going along. So I'm going to select all this, hit enter. Prints are a little slow. If you have lots of prints in there, it can slow down the process a bit, but you can see what happened was it went through each loop and it gave it a name, and these are all our transforms because we are printing the first argument in the list. If we had not done that, we would have gotten a list and we would have had the wrong item. So we want to get the first item in that list, and that is the height as it goes along. Let's undo and get rid of our print statement. And next, we want to make some room here, and we want to set the rotation. So we know our name, and we know that we can set the attribute by commands set adder, and our name is transform. That's the name each time. And we need to make sure that we turn it into the .rotate y is what we want to change. And we could have checked that by changing the rotate value from the channel box, and it would have printed rotate y, but I'll save us the trouble because I know it. So we're going to add that .rotate y. And if you wanted to make this even cleaner to read, you could do more steps here and say my adder equals this, and then it's easier to read step by step. You create more variables, but it's easier to see what you're doing. So we want to do my adder. Now, what do we want to set this to? Well, we want it to be in incrementing degrees. We want it to go around in a circle. So that means we need another variable because this needs to constantly change. If you said 10, let's do that. If you say 10, what's going to happen here? Oops. If you have some weird blank lines here at the end, sometimes it freaks out on you. So just make sure you select all this here. Okay, let's hit enter. Now, everything's still one after the other because, let's see the channel box, we set everything to 10. It's hard-coded. It can't do anything better than that. So, oops. All right. Sorry, it's really weird to work in this small screen space. There we go. Okay, so instead of doing a hard-coded amount, and let's get rid of all these, we need to make this a variable. So we need a new variable, and let's call it degrees. And we'll start it at 0. And if we switch this to degrees, you can see how we're starting to fill in the blanks with variables. We're taking out the hard-coded numbers and we're making variables. So every time this goes around in a circle, it's going to be degrees. So that means that next time we go in a loop, let's add to our degrees. Let's do 30 degrees. Every time it creates a new one, it's going to rotate 30 degrees. So it'll be 0, then 30, then 60, then 90. But if we go, well, I'll get to that in a second. No, let's do that now. Now, if we keep going for an extended amount of numbers, our degrees are going to get pretty unwieldy. So every 360 degrees, what if we just reset it back to 0 so that we're constantly going around in 360 degrees, and that makes much more reasonable numbers. I'm pretty sure Maya would reset it anyway for you, and give you the difference, but let's just, for the sake of doing this in Python, figure that out for it. So we want to say that every time degrees gets above 360, let's reset it back to 0. And we can do that test with an if statement. So we can say if degrees, and it's just like math, regular math, you can do greater than or equal to 360, and then we got to do our colon and jump inside. What do we want to do if degrees is greater or equal to 360? Well, we want to reset degrees. Now let's not reset it, but let's set it in case it were to ever go 370, and we want to make sure we get our spacing accurate. So let's say that it's always degrees minus 360. So that means that if we're 370, this would make it back to 10, and it would climb up again and then go back around in a circle like that. So we're resetting a nice clean degrees value every time, right? And so what we want to do now, I got something blinking, let me get rid of that here. At this point, we have everything we need to address our real-world problem of if we had that scene that had the missing textures and we wanted to fix all the missing textures in the scene in a loop automatically. We know everything we need to know now, so that's what we're going to tackle next, is solving that real-world problem. Alright, let's solve those missing textures in our test scene. Let's open up our Canon deck broken scene. And as we remember, the textures are missing. And let's get our script editor open. And we're going to open a new tab, Python. We got our clean tab here. Let's clean out the window, get something we can see here. Alright, so the first thing that we want to do is get all the textures in this scene that we want to work on. And what we can do here is, if I click on one of these items here and go to barrel, and it's telling us all the textures are missing, obviously. And if I jump into our texture, we can see what's important here is the type of node that this is. And if I scroll down here, again, bear with me with the small window, but you can see, okay, here's the image name. This is the image that this texture is pointing to, and it's a file node. So this is the node that we're looking for. We want every file node in the scene. And from before, we use the ls command. So if we do commands.ls, and doing that gives us everything in the scene, but we were able to limit the search by the type. So let's do type equals file, because that's the type of the node that we're looking for. And that gives us every file node in the scene. Now that we have every file node in the scene, let's save that into, let's call it file nodes. Okay? And then what we want to do next is we want to loop over every one of these file nodes and fix it. So to loop over, and we do for f in file nodes. F can be anything we want it to be. And we do our colon at the end, tab to go inside of our loop. And let's start off simple, and let's just select each one. So commands.select f, and you remember to do r equals true. That means replace the previous selection, which is a safe way to make sure that we only have one thing in our selection. And so this is a simple way, because now we can check out the attributes of each node. So and to verify that we are selecting each one, let's just put a print here, print f, and see what we're doing so far. So if I select all this, you can see that we are looping over every single file node in the scene, and we've selected each one as we went along. Alright, let's get rid of this print statement. And what we want to do next is we want to get the current path to the bad images, because we want to fix it. So we want to get this, and we want to get this image name, but that's not really the attribute we're looking for. And I told you that the easy way to get that is to just, you can just make a little space change here, and it'll print, see right here, it tried to set it, and it tells you it was setting file texture name. That's the attribute we want. So let's take this attribute name. And we just saw that by playing around with the attributes and seeing what they're called. So we've selected each one, and now we want to get that path name. So let's call this full name, because it's a full path name, equals commands.getAdder. And I had mentioned before that if we have selected the node already, we don't have to build the whole attribute name. We can just say dot file texture name. And to make sure where we're at so far, let's print full name. Alright, so we have got all the textures attached to these file nodes. And what we want to do next is we want to fix it. This is the bad part right here, because in our project we have a textures directory, but this part is all from Billy's setup. And what we want to do is, if we could just get it down to this, Maya will look inside the current, we've set our current project, you know, from setting the project, and then we've pointed it to our project directory. And so let's open this up here. Maya will figure out that it needs to look in this textures directory for all our textures. So we need to get rid of this front part. And to do that, let's start with a way that's built into these objects, and then we're going to look at how we can expand it later. But what we want to do is, because each string is an object, it has all these great things it can do. And like I said, just ignore the underscore system. Oh, Maya doesn't want to scroll. All right, let's try this again. Maya's being a little buggy with this pop-up window. But what we want here is we want to split. You see? Let's see if it'll show us some output here. Okay, we want to split this string. And what a split does, if we want to find out, is right? This will tell us split takes a separator and optionally how many times you want it to split. So let's get rid of this here. And what we want to split on is these path separators. Now bear with me because I'm on a Macintosh, and this would be correct for Linux and Mac, but for Windows you would have a backslash. I think Maya will fix it either way for you, but what I'm doing is somewhat assuming that it's a forward slash, but just for this example, let's do forward slash, and let's see what we get with that. Let's put a print in front of that. We get a list every time that split the path up by the slashes into its components. And what we want is the last, just the name. We just want to get the name. We'll build the rest of this later. Let's just take the name off here. So what I said that you could do before with lists is you can index them. So we want, and you don't have to, we could say parts equals, and then down here we could index parts being a list, but we could do this all on one line, and we could just say -1, and that says give me the last item of this list. And the way this evaluates is this says full name dot split. This becomes a list, and then on that list we're going to take the last item in the list. So let's call that name. Alright, so we can say print name. Alright, we got the name of every file. Moving along. Let's get rid of that. And now what we want to do is build what the name should be. So let's say new name equals, and then we want to do textures slash name, because textures without anything in front of it, this is a relative path. So this is going to say look in the textures directory under our project plus the path plus the name. Print new name. Alright, so now we've got our fixed name, and we want to put it back into that original node. Alright, so we want to do a set attribute. So commands set adder, and the first argument is the file texture name, and then we want to give it what we want to set it to. Now get ready for this possibly not working, and I'll tell you why. Alright, we got an error, and the reason is, and it's telling us where our error is. On line 7 we got an error with the set attribute command. So if you look down here, now it's saying that this attribute is not a simple numeric attribute, and you have to set the type if it's not a numeric attribute. So that's something, before when we were doing our spirals, we would just say the number 10 right here. So if it's a number, it doesn't need you to tell it what kind of type the value is, but because we are using a string, let's look at set adder. Actually, set adder. The type takes the name of the type, and we can pull up the actual name, or we can pull up the help. And I'm going to pull up the help right now. And if we go to set adder, you will see that there are all these types that you can define, and it's because it's a mel. This is all wrapped around mel, so mel needs to be told what kind of value you're passing it. And if we look down here in this list, we will see that the one we want, there it is. It's a string, so we have to give that type. So what we got to say here is type equals string. If we were, say, giving a color value, and this was like, 1, 1, 1 for RGB, then this type would probably be 3. And you can look that up in the documentation, but really all we need right now is this string. All right, so we should actually have this fixed when we do this loop. Let's do this now, and watch the path right here when we hit enter on this. You see what happened? The textures switched. All the textures are back in the scene, and our scene works. Now, we could say that we're done, but I want to do a little cleanup on this code to show a couple things that we talked about earlier. So I'm going to undo this. And actually, we could run this as many times as we want, but you know, I'll undo this anyway. We don't have to undo it, but I want to show you how to clean this up here. Now, you remember that instead of selecting each one, let's not change the selection every time we loop. Let's just build the proper string and put it in here. So let's get rid of this select. Right, and then let's build the right combination of this attribute and this path. Let's just say attrib equals, and you remember how to do it. We could add them together because they're strings, but you remember our string formatting. If we do %s dot file texture name, and then you do a % at the end, and that formats the f into this pattern. Now we don't have to say that attribute. We just pass our attribute. We can set it down here as well. Right? So that cleans that up. We don't have to change the selection every time we go around, which is nice when you build a big script and you don't want to have to change the selection constantly when you don't have to. And another thing that I want to change is, remember when I said I assumed this slash to separate paths, you know, and that works great if you're on a Mac and you're on Linux, but Windows, you know, you could have issues when you're assuming that kind of separator. So I want to make use of a module now. And one of the cool things is the OS module that we showed in the examples has a sub-module called path, and that's for doing things with path strings. So we can say import OS, and I could just run that by itself. And OS has a module called path, right? And path, one of the things that path can do is it can split. And it can split using the proper separator, not you telling it what separator, but the actual proper one for your system. So let's fix this line. And the way it works is, let's go down here and get some help. os.path.split. It splits a path name. You just have to give it the p string path name, and it returns a tuple, which is like a list, but you can't change a tuple, in two parts with the head and the tail, where the tail is everything after the final slash. So that's pretty much what we want it to do right there. We want to say os.path.split, right? And that's going to give us back these two parts, but you remember we need the last part, not both of them. We need just the last part to give us a string. So we need to still do -1. But the cool thing is we didn't have to assume the separator. It'll do it for us. And let's also fix this texture name here while we're at it. Actually, let's make use of the OS path again. There's another item called join, which is the same thing but the other direction. If you give it two or more path name components, it will insert the slash or whatever it is for your system. So let's say os.path.join, and this takes, you don't need the slash because it'll figure that out. You give it as many pieces of the path as you want, and it will join them together into a string. And we can run this again, and we shouldn't get any errors at this point. See? And it ran, didn't give us any errors, but it still did everything it was supposed to do. So that's how we clean up the code and make use of some modules, and we fixed our scene, and now our scene has textures with no errors, and I will save that out as the fixed scene. So that takes care of our texture fixing scenario. In this chapter, I want to get a little more in depth about development in Maya, some details about what's available to you. And I know I talked a little bit about